Now we are going to discuss alkanes. When you have a large number of carbon compounds from different covalent bonds between carbon atoms, one example is C3H8, where you have 3 carbons and 8 hydrogens. They are very strong and normally allows carbon atoms to form long, stable bonds. Before we move into the properties and the different reactions, we have to know how to name them according to IUPAC. Alkanes, when you are trying to name them, you have to identify a continuous chain of carbon atoms, and the name will end with ANE. ANE. And we have to use Greek prefixes to name carbon chains with 5 or more carbon atoms. Now, this is the table which shows what prefix we have to use depending on the length of the carbon chain or the number of carbon present in the compound. If you have 1 carbon, it is methane. If you have 2 carbons, it is ethane. 3 carbons, propane. Everything ends with ANE. Ane, that represents alkane. So if you have 5 carbons, it is pent. 6 carbons, hex. 7 carbons, hept, and so on. For a condensed structural formula, we have already learned that each carbon atom and its attached hydrogens are written with the respective numbers, and the subscript indicates the number of hydrogen atoms bonded to each carbon. So if we consider the expanded formula for this carbon, it has 3 hydrogens attached. For the condensed formula, we can write 1 carbon because we have 1 carbon here, and 3 hydrogens having these 3 written as H3, and 1 bond which is not bonded to anything, that is an open bond. Similarly, this CH2, where 1 carbon and 2 hydrogen and 2 open bonds. So CH2 and 2 open bonds in the condensed formula. There's another way of drawing these hydrocarbons, which is known as line angle formula. It is a zigzag way of drawing a line depending on the number of carbons you have in your compound. For carbon atoms, if you consider the ends, they have 3 hydrogen atoms. And if you consider the middle, which are bonded to 2 hydrogen atoms. I always suggest students, whenever you are drawing any type of alkanes, you have to consider that carbon can have a maximum of 4 valency. So whenever you write carbon, you have to adjust the 4 valencies, and you can add hydrogens according to that. Now for this problem, we have to draw the expanded condensed structural and line angle formulas for pentane. Pentane is pent, that means 5 carbon. So we have to draw 5 carbon. We have 1, 2, 3, 4, and 5. Now for the expanded formula, depending on the valency of carbon, we can adjust the number of hydrogens. So in this case, the N1, we added 3 hydrogens and other bond is connected to carbon, so 4 valence is fulfilled. The middle one, which is this one, 1 carbon attached to 2 more carbons, so 2 valences are fulfilled. We have 2 more left where we added 2 more hydrogens. Similarly, more CH2s, and the N1 is CH3. For the condensed formula, once you have drawn the expanded formula, we can directly convert it to condensed structural formula. So we draw C and 3 hydrogens as CH3. The next one is CH2, 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 and CH3. Once we have drawn the condensed structural formula, we can convert it to the line angle formula. How? Each peak represents the number of carbon atoms. So we have 1, 2, 3, 4, 5. 5 carbons, and then CH3, CH2, 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 CH3. Because the line angle formula, the N1, they have CH3s or 3 hydrogens, and the middle one, they have only 2 hydrogens. Conformation of alkanes. When you have carbon atoms in a chain, they are connected by CC single bonds. They can rotate so that the groups attached to them, for each carbon, they can move freely around CC bonds and they can generate different arrangements. Some example of drawing different structural formulas. In this case, we have butane, which is 4 carbon and 10 hydrogen. The table shows you how to draw the expanded formula, the line angle formula, and the condensed formula. Cycloalkanes. The name tells you that it has a cycle involved. So they are cyclic alkanes. They have 2 fewer hydrogen atoms than any open chain form. They are named by using the prefix cyclo before the actual name of the alkane. So if you consider propane, whereas you have 3 carbons and open chain, that is propane. But if you consider cyclopropane, there you have 3 carbons, but they are in the form of a triangle. So they are attached to each other. If you consider hydrogen atoms, cyclopropane has 6 hydrogen, which is 2 less than regular propane, where you have 8 hydrogens. This table represents some common formulas of some cycloalkanes, the ball stick structure, the regular structure, and the line angle formula. Cyclopropane, cyclobutane, because we have 4 carbon in a cycle form, cyclopentane, 5 carbons in a cycle form, cyclohexane, 6 carbon in a cyclic form. Let's try naming these compounds according to IUPAC. The first compound, which is compound A, we have 1, 2, 3, 4, 5, 6, 7, and 8. If you have 8 carbons, it is named as octane. And this is a cycle. We have 1, 2, 3, 4, and 5 carbons in a cyclic form. So it is cyclopentane. You can try naming these following alkanes. 4 compounds, 2 of them are regular straight chain and 2 of them are cyclic compounds. Based on the number of carbons, if you name them, you get the first one as butane because we have 4 carbons. Second one, 3 carbons in a cyclic form, cyclopropane. Compound C, 8 carbons, octane. And the last one, which is compound D, a cyclic form, 6 carbons, cyclohexane.